So here is the second lecture for this unit on research methods in psychology. So we'll look at different ways that psychologists do the work that they do to figure out why people act the way they act. First of all, you have to understand what sort of perspectives scientists take. And this is a really difficult thing for a lot of Americans to understand. If you read comment boards on newspaper websites or Facebook, you see a lot of really poor understanding of how science works. So I want you to walk away with this with a clear conception of what the core values of science are and how science does its job. First of all, science strives to be objective, knowing that people are not perfect and knowing that we do make mistakes. And so you have to take everything with a kind of tentative, this is mostly probably true until I get evidence to the contrary. The goal, though, is to try to take yourself as much out of the process as possible so that your results aren't contaminated by you and the way you think. And there's a great deal of press about this, particularly when science is paid for by companies that have agendas and interests that sort of color the work that is produced. One of the things that can help with being objective and being much more scientifically minded is to have clear, precise definitions for how you measure data. And this is very hard for a lot of people to understand in psychology. If you design an experiment that's supposed to measure the effect on chewing gum on happiness, you need a definition for happiness, as well as a definition for what kind of chewing gum, how much chewing gum, how long it should be chewed. If you don't have clear definitions for how you're measuring data, the results that you get are essentially meaningless. They don't really hold up for anyone else who wants to try to recreate what you've done. So you have to define your terms very clearly in psychology. Third, we need systematic observation. You can't just sort of observe when you feel like it. You have to have a method for when you collect information about what you're studying and how much data you're collecting. You can't just observe once and be like, oh yeah, I observed, chewing gum made this person happy. It's got to be systematic, every 4 hours, every 2 days, with 100 people. It has to be very, very well documented so someone else can try to repeat your experiment or repeat your observations and see if they come up with the same conclusions. This leads to replicability, which is a big fancy word meaning we can replicate or repeat your results. Generally, psych experiments and psych information is best when it has been repeated by different researchers who get the same results. This is important, I think, for most of us to realize that sometimes when the news reports an experiment, it reports one single experiment as if it is now scientific fact. When, if that experiment were to be repeated, you might end up with different results, but you might get the same results. We won't know until somebody repeats it. Just like in your regular science question answering sort of methodology, we follow the same sort of standard steps in psychology. For example, we often come up with a hypothesis. Because we're dealing with humans, most often the hypotheses are things that we've observed about people, and we think, I wonder if this is what explains why people act that way. But you have to state that and then design an experiment that allows you to figure out if that hypothesis is true or not. We When we say the word truth in psychology or science in general, we basically mean testable. A hypothesis should generate something that you can test to find out if it is confirmed by repeated observations. If I repeatedly observe you chewing juicy fruit and then measure you to find out that it makes you happy, then I might hypothesize that chewing juicy fruit induces happiness. When I can do that, it might help me develop a theory, which is a set of facts and the relationships between those facts that explain and predict related phenomena. So in my example of juicy fruit, let's say I observe that juicy fruit makes you happy. What's my theory behind that? My theory might be that juicy fruit induces happiness because the flavors of juicy fruit are designed to mimic natural sweeteners that induce in humans a feeling of well-being the same way that taking in real food does. So I might have the hypothesis chewing juicy fruit makes you happy, but the theory explains why that happens. And a theory is not an educated guess. That's what a lot of the public thinks that a theory is. Oh, it's just a theory. Anybody who says that on a comment board doesn't understand what the word theory means. In science, it is the best explanation we have for the data we can observe. And that is a very important distinction between the way the public thinks about the word theory and the way scientists do. Just like in your biology class, or your chemistry class, your physics class, we do the same set of steps in psychology. We observe some kind of behavior or phenomenon, and we think, that's an interesting behavior. I wonder why that happens. We formulate a question to ask why we think that happens, what's going on. We generate a prediction that if X happens, then Y will be the result. And then we create an experiment that allows us to test that, to figure out if that is really the case. We do all kinds of repeated collection and analysis of data to figure out if that's the case. And then we draw conclusions in order to create a theory about why the behavior we observe happens to be happening in this particular circumstance. Many times in psychology, what we know about human behavior occurs in non-experimental ways. And that's because people are very hard to put in experiments. There are a lot of things we'd like to know, but experimenting would be horrible. And so we can't use experiments to find out. So there's a real need for using non-experimental methods, but here is the one key understanding you need to have about them. They cannot find a cause-effect relationship. Non-experimental methods might suggest a cause-effect, but they don't manipulate people in order to find out if there is a cause-effect. In fact, non-experimental methods are merely observational. You watch and you see what happens. You might have a guess as to what's going on, but you can't show cause or effect with non-experimental methods. One of the most common ways is just naturalistic observation, where you look to see what's happening in the real world. You observe a subject in its natural setting. If you want to see how frat boys behave in bars, you go to bars and then you observe frat boys acting and see what goes on there. Or you just watch all their Snap stories. The big difficulty with naturalistic observation is to not let the people know they're being observed, because it might change their behavior. When people know they're being watched, they act in ways that are different than they would normally. Case studies are another way of getting data about someone's behavior. But typically, these occur when you've got a person with a unique problem. Someone with a disorder or difficulty or an interesting behavior that you want to study in great detail. If you want to find out about a lot of people's behavior all at once, then you would do a survey. Surveys give you a lot of data, whole bunch of data. They tend to be pretty cheap. You can do them easily over the phone, paper and pencil, walking up to people on the street. So you get a large amount of information, but the problem with surveys is that they are self-reported data, and that may be false. People sometimes lie on surveys in order to avoid saying something about themselves that might be perceived as negative or that's socially undesirable. When you do surveys, polling and statistical measurements of the surveys do cause some problems for the American public in trying to understand what those statistics mean and how they should be interpreted. This is probably the single biggest mathematical problem for modern Americans. I'm a big proponent of having everyone take statistics because we misunderstand stats so much on a day-to-day basis. And stats is so important for public policy, for the economy, for science, that most Americans just don't understand or get statistical reasoning at all. When you do have a lot of statistics, you can do what's called a mathematical correlation study. That is where you take two sets of stats and you find out if there's a relationship between the two of them. Correlations simply measure the direction and the strength of a relationship between two variables. And that direction can be a positive direction, it could be a negative direction. And it could be very strong, or it could be very weak. For example, let's say I collected data on the number of donuts I eat and then the size of my pant waist. If I eat one donut, I'm 30 inches, two donuts, 32, 3, 33, 4, 35, 6, 37, 7, 40. It looks like the more donuts I eat, the greater the number of donuts. So as the number of donuts goes up, it looks like that the size of my pants waist also goes up. It seems that there's a relationship there. As one increases, the other increases. We can make that relationship have a number or be calculated as a number. That number is called a correlation coefficient. 0 means there is no relationship between the number of donuts and my pant waist. If there is a positive correlation, it can run from 0 to 1. The closer you get to 1, the stronger the relationship. So we can actually also graph that. Here is no relationship, just random scatters of data. Here is a little bit of a relationship. Notice that if I were to draw a line of best fit, it seems to go roughly in this direction. If the correlation is perfect, that is, there's a clear, strong relationship between the number of donuts and my pants waist, you'll see it come out as a line. Now, this can also be negative. You can have negative correlations, line of best fit, or in this case, it's perfect, and that runs from 0 to -1. Now, this sometimes is misleading because people think -1, there must be nothing there because it's negative. But a -1 correlation is just as strong as a +1 correlation. So this correlation coefficient is merely a number representing the relationship between the two variables. It's strong the closer it gets to 1 or -1, and weak the closer it gets to 0. So we call the ones that are positive where it is a set of data that rises and the other one also rises. Negative, as one set of data rises, the other drops. You might have talked about that in mathematics as an inverse relationship. They're inverted. As one goes up, the other goes down. The big point to walk away from, and this is something that science writers and the American public does not understand in general, correlation is not causation. A relationship between two variables might exist, but one variable might not be causing the other at all. In fact, there are many things that are correlated, that appear to be related and yet have no relationship at all in the real world. So it's very important to remember, anytime a study is reported on the news that says, consuming chocolate lowers your risk for a heart attack, that might be a correlational relationship in which people have observed chocolate lower risk for heart attack. But it might be that there's actually no relationship at all there until scientists figure out how chocolate might lower your risk. And the reason that there might not be a relationship is because of a third variable. A third variable, or a confound or confounding variable, may be influencing the relationship, and you may not be measuring it, you may not even be aware of it. So my pants waist might be increasing not because of the number of donuts I eat, but because I might have an underlying medical problem or some other kind of difficulty where my size of my pants waist would increase. Let's think for a minute about methodologies that you would use in certain settings. Let's say you want to see how students in class react to a teacher when she wears regular clothes instead of dress clothes. So what do you use there? Is that a survey? Is that a correlational study? Is that an observational study? Is that a case study? That would be an observational study. You want to see students in their natural setting reacting to a change in their environment. How about if you want to see if you can learn anything about behavioral therapy for a child with a rare form of autism? You're right, it's a case study. Rare form of autism, so you probably only have 1 or 2 subjects, and you're doing therapy with them and then documenting how that progresses. Is there a relationship between grades and start times for the school day? You're right, it's a correlational study. Numbers of grades, so grade levels, start times, you can mathematically plot that. You want to find out what teenagers have in terms of their attitudes toward the habitual usage of marijuana. You're right, it's a survey, provided they don't lie on the survey. Studies get reported incorrectly all the time. And they often get misrepresented, or they are badly designed in and of themselves. So it's important that you, leaving this class, be a good consumer of psych literature so that you can point out when things are not right. Dave, a clinical psychologist, believes that touching helps clients in therapy. For 2 months, he touches half of his patients, group of A, and doesn't touch the other half. Group A improves in therapy. Okay, well, beyond the problem of the fact that he is touching his patients, that's an ethical problem. How do we know that the touch itself is what improves the patients in their therapy? How do we know that Dave isn't changing his therapy in those patients in Group A, and that maybe he is doing a different kind of therapy in Group B? How do we know that Group A's patients have the same kind of problems as Group B's patients? As it's reported here, it's not clear what exactly is causing the improvement in therapy in this particular setting. A researcher interested in attitudes toward premarital sex sends a survey to readers of Vogue and Cosmopolitan. Why would you pick readers of Vogue and Cosmopolitan? If you choose those two groups, you might get a different set of responses than if you chose readers of, I don't know, say, the National Review, the Inquirer, the Biblical Recorder, which is actually a magazine popular among Southern Baptists. A newspaper reports that violent crime is correlated to phases of the moon. A reporter concludes that violent crime is caused by the moon's gravitational pull. Correlation's not causation. How would we know that the moon is actually causing an increase in violent crime? We don't. One of the problems that psychologists face in designing experiments is figuring out how to get a population of people to experiment on, or to study, or to observe, or to write up as a case study. Human subjects are necessary in psych because psych is about human behavior. Getting the right kind of human subjects always poses a challenge. When you are designing an experiment or trying to do a survey or do an observation, you need to figure out who your population is. A population is the group of people under study. Are we studying the behavior of teenagers? Are we studying the behavior of married, middle-aged women who are middle class? What is the group of people under study? Because behavior might vary depending on which group you're talking about. Once you find the population, you've got to figure out how to sample that population. Psychologists typically like random samples, meaning that they don't ask every single person in that population. We can't. It'd be too expensive. Instead, we would like to find people at random so that we can be sure that our results were influenced by choosing certain people over others. If I design a study where I pick certain people, I could change the outcome. But if I design a study where the people get picked randomly, I can be more sure that my results are due to something other than me selecting people in a biased way. But once I select a sample, I have to figure out if my sample represents the whole population or not. Does the group that I've picked reflect the group of people that I'm studying? If I want to survey premarital attitudes of teens toward premarital sexual activity, I've got to define who counts as a teen. I got to figure out if I'm surveying only teens in Alabama. Am I surveying all over the United States? Am I picking teens who are both heterosexual as well as homosexual? Teens who might, for example, be bisexual or asexual? You know, you need to get a wide range of those folks so that you can make sure that your results don't reflect a very narrow group of people. So in our little sample over here, we have mostly red folks in this sample, so we got 2 reds. We got green folks, so we got 1 green, and 3 blue folks, so we got 1 blue. And we've picked them at randomly so that this reflects generally the same as the population itself at large. Now, if we are doing our population sampling for an experiment, we are then going to manipulate a variable to see how people behave. The variable that we are working with is called the independent variable. It's not a name that makes a lot of sense to students studying science. The independent variable is the cause. It's the one that is getting manipulated. That's the one that's being sort of played with by the psychologist. The dependent variable is the effect, and it's the one that results from the psychologist's manipulation of an independent variable. So it depends on the independent variable. Do you see where they got their names now? Now, we don't, in an experiment, manipulate an independent variable on one group of people, because that gives us nothing to measure against. What we need is to have 2 groups of people. We need a group who gets manipulated by changing the independent variable, and we need a group who don't get manipulated. The group who gets manipulated, we observe changes in their behavior, and we compare that to the people in the control to see if there's anything significantly different between the 2. That gives us something to measure against. Something to say, yes, when we manipulated this independent variable, it caused people to behave this way, but people in the control group did not behave that way at all. So these are terms that you're going to have to memorize and just know cold, because they will show up in test questions, in examples of experiments, as well as when experiments get reported in the news. So experimental group goes with independent variable. Control group doesn't get manipulated in order to see if the independent variable actually does have a relationship for the dependent variable. So basically, if you were to diagram it, it looks like this. An experimental group gets manipulated with the independent variable, and that should show a change that we call the dependent variable. This random representative sample would also be used as would also be pulled into a control group who don't get manipulated, and therefore we can compare these two to see if this change actually really does make a difference. Now, there are all kinds of problems with experiments. So even though experiment is the only thing that can prove cause and effect or show cause and effect, you can have problems in the design of your experiment. Confounding or extraneous variables might come into play if you've not designed your experiment well. And sometimes it's really hard to design an experiment so that you can remove all confounds. Psychologists have to work really hard to design experiments that take out these extraneous variables. Other sources of experimental problems would include the bias of the experimenter. When the experimenter treats the participants differently in the experimental group versus the control group, it might send an unconscious or subtle signal that could change the outcome. When an experimenter interprets the data in a way that leads to a more favorable conclusion, that also can cause problems in the experiment as well. So it's very important for the experimenter to keep his or her own bias out of the experiment and his or her own bias out of interpreting the data that he gets at the end. And there are ways that we can do that. One of the best is called a double blind. In a double blind, neither the participants in the experiment nor the researcher know who is getting manipulated, who is getting the independent variable. So all of this is done in a way that preserves the anonymity. And you can even do this with the data at the end. You can run statistical analyses of the data so that the results come out in a way without the experimenter being able to modify or change those results. Most of the time, this is used in drug studies. So for example, you might want to test a new pill for weight loss to see if it actually causes weight loss or not. If the drug company wants to make this pill, wants to make money off of it, they might have an incentive to change the outcome. So a double blind makes sure that neither the researcher nor the participants know who's getting the pill. Everybody takes a pill, but some of the folks actually get the weight loss pill, other people just get a sugar pill. So let's say, for example, we're going to look at an experiment on does listening to music affect learning. So we've got a population of people that we would study. We would randomly assign those people to either the control or the experimental group. We would create identical conditions. We wouldn't manipulate anything in their conditions, so they would study under the same conditions, do everything the same. But in one of them, our independent variable would be the music. In the other, there'd be no music. And then we would measure the results to see if there was a difference with the dependent variable. And the whole time, we would try to make sure that we keep our own biases out. We would make sure not to change the outcome by the way the experimenter reacts with the people, either in the music situation or the no music situation. What if you want to study people over time to find out how they grow and develop? Well, psychologists also do this. This is not exactly easy to do because it can be very expensive to run experiments for several years. One of the ways that psychologists get around it is a cross-sectional design. So you take people at various ages, so 1, 3, 6, 10, 14, 20, and you make them go through the same experiment to see how it affects them at different ages. Can you see a problem with that? Well, because they're not the same people, how do we know that in a cross-sectional design that the results aren't due to the fact that we're looking at different people who are at different ages? You could do a longitudinal design in which you study the same group of people over many years. And if you do that, you would be able to see the same person over time in the same situation. So it's, this one individual as opposed to different individuals. But can you see a problem with that? Yes, that's expensive. You have to wait a long time for people to grow and develop. So I give you this test at 1, then I give you the same test at 5, and then I give you the same test at 9, and then 12. Then what happens if you die? You might lose your subject because they might prematurely, pass away. And then you've suddenly lost a whole section of data there. When you are doing these experiments, when you're doing observations, when you're doing studies on people, you have to be very careful to be ethical. This wasn't always the case, and we're going to read some examples of really unethical, horrible experiments that were done to people over time. Today, the American Psychological Association has ethical guidelines for how psychologists are supposed to work with people. The chief guideline is to do no harm. If the experiment is going to hurt human beings, then that's just a big no. Hurting people is not acceptable. Secondly, you should do informed consent. Describe the risks of the experiment. Describe what could happen to people so that when they go into it, they know what could happen to them, what dangers might occur. Participation must be voluntary. People have to have the right to choose to be in the experiment. They can't be forced, because if you're forced, well, that just changes the outcome. You must protect people's confidentiality and privacy. If people reveal to you things that are embarrassing or troubling or difficult, you cannot go and share that with other people. And that includes things revealed in therapy, things revealed as part of test scores. You have to maintain people's privacy. No gossiping. You can deceive people, but only when it's necessary for the experiment. So if you have to lie to people in the experiment in order to test a hypothesis, that is acceptable as long as you don't harm people. And then afterwards, you must debrief them. So explaining what the deception was, why you deceived them, and what the results were. Now, if your experiment has caused any harm to people, or any, sort of difficulty in their lives, you have to provide them with counseling and therapy. You cannot release damaged people back into the world after having manipulated them. It's not fair. It's not right. And then people have the right to withdraw at any time for any reason without being made to feel guilty about it at all. So participants have the right to back out of an experiment. One of the most ethically questionable experiments was in the mid-20th century on syphilis, the Tuskegee syphilis experiment. About 400 African Americans, mostly poor men, were recruited by the U.S. Public Health Service to test the progression of syphilis. Many of these men died from their disease. Several of them died, actually the bulk of them died from complications due to syphilis. They gave it to their spouses. They passed it on to their children, all in an effort to sort of understand, how this disease progressed, and then test the effectiveness of penicillin. Some of them were not even given, penicillin to even treat them. And so this was a horrific violation of their human dignity and their rights as people. The U.S. government eventually apologized to the descendants of the participants. I think the last descendant died in 2005. So whenever you're designing experiments, you have to weigh the knowledge that you might gain from an experiment against the treatment of another human being in a really poor and horrific way. So ethics has got to be a core part of the psych experience, in not just in experiments, but in therapy, in surveys, everything that you do as a psychologist.